Okay. And this should be live. Yeah, I think Google knows of it. Okay. And this should be live. Yeah, I think Google knows of it. Okay. And this I might be echoing, right? Ooh. Unfortunately, I have not the time to edit anything. Anyway, let's switch to streaming, which is what we said we do. And let's share the whole screen, namely, wait. They are so similar because the other one is showing the live stream. Screen 2 looks wrong. And it should be the white one, screen 1. Okay, go live. Yes. It's good. I see. URL. Okay, and Discord go away. Yeah, just this morning I reconfigured all my hardware. I was streaming before on my older desktop. I bought a new machine with many cores, 24. Latest greatest Ryzen, not exactly the biggest one, but second tier one at the time. So I can run my many standalone compilation tests. If you've ever used Nuitka, you know that one compilation is very taxing, but I obviously have to do many more than anybody else. So what have we got? So I wish I could see the streaming channel. If somebody joined that, and the that's not going to happen. But I think you can chat in the streaming channel, and I think you do not automatically get voice. So yeah, go over, say something. Okay, where do we want to go? The draft. A few hotfixes have been made. The first one is always the more important one. What people have been asking a lot in the past is support for Torch and Torch Vision. That's not a regression, it's actually a feature fix and has been done largely with, let me start Visual Code. Has largely been done with anti-bloat work. And there has happened also a lot of things. The YAML files are all now merged, have a schema description and some checking for values in Visual Code directly when you edit. But basically adding support for Torch, let me do it here. Debugging some sort of problem here. Anti-bloat, no, that's because it's this one is the Visual Code from my CI machine, or maybe my former CI machine. I might be switching it to be my real desktop now. because it's still faster even if it runs with CI in the background. And the file is now named like this. And for example, if we search for torch, we find, for example, DLLs to include for torch vision. Or here we have a workaround. So actually Nuitka does not put a module as the code name, but puts also the module name there. That's making life easier in case of troubles. But it's not entirely compatible. But some people think that you can test for something to be a module with that. That's obviously not true. I could cheat it. But yeah, but more or less it does just the code replace here. Here is some warning about just-in-time compilation not being done anymore. That's not interesting, so we disable that. Then we have implicit imports. The operation sets here are required in any case, so but these are not visible as dependencies. Imports built at runtime. Nuitka reflects them here. And here we have another hidden dependency. And what else? Oh yeah, there we are. And what was the other thing? Torch and could also actually look at the commit from the hotfix branch, but that would be too easy. TensorFlow. That's the other one. TensorFlow had some work before. They do some stupid copying of functions that's not needed really. And they try to patch doc strings. We also don't care. And the way they do it is also entirely wrong. So I just disarm it here. And then we do some anti-bloat work. I do this a lot to make sure the compilation doesn't require dist-utils version and does just string-based comparison, which are good enough these days. And same goes here, and here, and here, and TensorBoard. Yeah, tries to load some IPython. We just don't do it. There's no notebook, unless a check would be set to allow IPython. So if you wanted to compile IPython with TensorFlow, then this would be what you're doing. And more implicit dependencies, this kind of thing. So let me check. Yep. And here we are with that. But Firefox. Oh wait, I meant to. I probably disabled video, right? Yeah. Yeah. Here I am. That was the hardest part this morning to set up. And audio, and I don't know. I have a need for a more switchable USB hub. Actually, my monitor does that. But what should I say? It only has 2 slots right now, and I might have to buy a USB hub to plug into that switchable USB hub monitor. Well, okay, so here we are. So that's the TensorFlow. So in terms of news, big one, OpenCV was already dealt with, of course, with 0.8 release. So actually, if you download 0.8, you get this. This is actually a corruption bug. There are a few corruptions still in Nuitka that are plaguing me, and I'm searching for them. I do that by running more and more test suits in Python debug mode, and doing so found this one, which actually should have been the one I'm looking for, but apparently was not. And this is just wrong optimization. This one is actually pretty funny. It could compile and crash. Yeah, it didn't check if the keys were actually hashable. Just assumed they are, because of course code you are going to compile often is. But I think I did some cleanups in this area to make optimization apply more universally, and then I understand with the pairs, and I noticed this is not done. So that's actually the only reason I know it. And this one, these hard imports. So when you import lib resources, you get a name import lib, but you still have to import lib resources. Is kind of different. Took me a long time and delayed 0.8 quite a bit. And apparently only in 0.8.3 it's entirely ready. So macOS, there has been some work for hardened runtime signing and for notarization, but it's not complete. There's a NoQt plugin. That's actually something I want to have for testing that prevents all QTP bindings from being compiled in. So if you know that you do not use PySide, PyQt, and whatnot, this will actually accelerate your compilation quite a bit. And also get rid of these enable the plugin warnings that you were getting. And the module search path in compilation report. That's actually something that I intended to use, but for the reflected test. But I found that we have another way of doing it. Yeah, basically it's like now that we do hard modules imports, it's very important that we find the same set of modules with a compiled Nuitka and the uncompiled Nuitka. Then I found that we can make a replacement for PyDigNext. And that should be slightly faster. That's actually pretty easy stuff. So let me go here. Nuitka dict next. There we are. Used like this, much the same as the original function. And this one is just going to do slightly less tests while iterating the dictionary slightly faster, better for inlining. And especially on Windows, every dictionary iteration had a DLL call overhead per dictionary key value pair. So that should help Windows, which enforces DLL. If you can avoid it, and then the gain will be still there, but very low. Stroke count, I tried to complete it a bit. So I have most of the functions, and I actually started working on stro format, but I stopped on that end because I noticed that the call code needs to become reusable. And this is tying in with the next bit of thing. So when we build a dictionary or we make a call with a dictionary, we often have something called pairs. And the pair is this one. And yeah, it has two values, a key and a value. And it was very general. So this was actually two nodes that were visited during optimization and could change. And one of them, the key, happened to be very constant all the time. And now there are specialized variants, which maybe I show what I mean with specialization once. Key value pair nodes are now in a different, actually So key is already a constant here, and it creates a different one, and constant key value has no children that would be named children here. If I compare it to this one only has a constant key but has a named child. And then during optimization, that's a separate node. Could be anything, could be but not a compile time string. And then it is like that. These do not warp into each other's yet. And that's a big memory saver and compile time saver. So because these are so frequent, a lot of churn would be done to this. But generally, where I want to get is to have a pair set. So a call has a set of keyword arguments. Is it a set? Yeah. A sequence of keyword arguments. And this sequence should also be one thing and potentially be used in more places. And using a dictionary for a call should be the exception. So Python deep down often requires you to build dictionaries, but Nuitka makes optimizations to avoid that. And with vector call, Python also often allows to not do that. But for example, str format takes arbitrary arguments, essentially pairs, and needs to store them. And I want to have this make the call code reusable, but I'm not there, but this is an important step towards that. Then, of course, a lot scalability work has been made. I have done a lot for matplotlib, which is frequently used by many things. And it's much faster to compile these ones. Now much less modules. Obviously, every other module may still do stupid things when it's included, but importing matplotlib is no longer breaking your back. And faster chords in Mixer. Yeah, that was a missing optimization. They did something nasty. They changed an API. There was just a pointer check to a subtype check without changing the name. And now Nuitka still does again the pointer check. So actually that was a performance regression for Nuitka from 3.8 to 3.9. That got removed, and we have duplicate and non-existent entries in search path. Yeah, so when the directory was 2 times in the search path, Nuitka would look at it 2 times, searching for a module. That's of course stupid and wasteful. And if it doesn't exist, if a directory doesn't exist, it would always try if the module below it maybe exists. Also very wasteful. And especially Windows, I think it's pretty slow on I/O files, and might help. At least it made things cleaner. Yeah. Then we have a big YAML file merge. That's actually a guy named Firebase did for me, and also did most of the schema he created, the description and so on, and auto format. So when we looked at this, that was actually, can I still open? Yeah, I can still open. No, I cannot. That's now done by schema. I think it was structured entirely different, but that's very unfriendly to a checkable schema. So now I can actually type here and have support for, and then it will tell me, for example, that's not a module name. Okay, that's not what it says, but that's what it should say. And then here, wait, what should it not? But it will complete and know the keys and so on. So this is actually a lot less dependent now on copy on paste to get right. Previously, I could only do new entries by copying existing ones. Because, yeah, should there be minuses, should there not be, should there be indentation or not? Actually, if you're a YAML expert, it may be obvious to you, but to me it wasn't. And I think I also created the schema in slightly non-optimal ways. Because of that, we are going to clean it up more. Now, that's a very important point. When people do PRs, we don't use the commit hook apparently. So it's more clearly pointed out in the PR template. Actually, now that I think of it, maybe pull, oh, what's this? Pull request template, commit, enabled git hook, auto formatted code. Actually, the blue thing you see is like I have a spell checker and a lot of changes that I've been doing recently, correcting wrong spellings in Nuitka code. Auto formatted code with I don't have a proper keyboard configuration apparently. Ooh. Hold on. Now that's going to show off my master skills here with Windows. Keyboard. Yeah. German one. Eingabe. Where does it say? Where does it say which layout I have? Okay. Actually, I don't want you to have voice at all. But Can I? Gabe? Oh, Sprachausgabe. No. Should be here. Am I going to copy characters now? It's been a long time since I've been not annoyed by Windows forcing me to see language switching. How embarrassing. Now works. Yeah, actually, I have a German keyboard, which many people will despise. That's a spelling mistake in the binary name. Okay, that's slightly more. Yeah. You can see here, this is also some spelling mistake corrections that I've made. So this is my private dirty Git. This is whitelisting something. Basically renaming the class. There was an R missing in progress bar. And actually that's kind of something that can prevent me from finding important things. This is me debugging. So is this all it is? Here, and then it's being created by a local, so it's a local thing. Minor stuff. This is my very, very dirty Git. I copy later the code into the public Git, and then I make nice commits, but I don't do that immediately. And my private CI just lives off the dirty branch. Okay, so I was going over this the PR template. Of course, the commercial version output nicer. Okay, updated the new Ming W WinLibs. There were complaints about the old one being susceptible to viruses. GCC 12 is on WinLibs, or was on WinLibs. 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 And but it doesn't have. There is no CLang in this archive, so it's basically only the without download. And yeah, the reason it's not in there is because it was not as mature, so I'm leaving that off. If somebody were to find out how much better or not the CRT is, for example, if you check it out here, that would be sweet. I would very much welcome a pull request that does either of these. I think using the Microsoft runtime might be a bad idea these days, but maybe I'm wrong. Okay, so that's the changelog. And what I have in stock for today, nothing in the chat here. Nothing in the streaming chat. Where would I see the actual streaming chat anyway? I just got informed by Twitch that we have a feature that apparently, it's very unlikely I'm going to see this. So YouTube comments are probably your best bet because they are clear in my plain sight. And okay, now what I did the other day, and I think it's should be nice to look at this. So actually what I have here is like a Linux checkout usually, and I have another visual code with the Windows. And I'm not going to push this. I'm going to fetch. Hold on. Git checkout. Git branch minus dvip. Okay, there's no. Then I can just switch here, right? Set up whip. Okay. So, yeah, throw away this one. I was just checking if print flushing is any better than file system flushing. Actually, the issue I am debugging here is stray outputs during compilation. Very, very annoying. Anyway, okay, I wanted to show branches. Iterator Tracing. Is this only one? Yes. Where is it? Wasn't it so that you can compare branch? Yeah, but the working tree is not the right one. Ah, yeah, compare with main. Okay. So it had 18 files changed. So this is something really big and advanced that I did. Where do we start? We start with the example. So this is the code I'm actually trying to optimize. And it's really shameful. Well, it's disappointing that it wasn't. So what existed was some old iterator tracing, and this iterator tracing basically took note when an iterator was created, and then every time something was taken out of it, for example here, it would take note and increase a number and decrease a number, and at the very end of a tuple unpacking, you check if the iterator still has values. And you do that by asking the iterator next again and ignoring the error, actually expecting the error, complaining if it's not happening. That's how you tell that you had more values to unpack. So that would be important in this case. Okay, and that was actually something that it did. So it measured the length, and the idea was if I correctly pass all the tests with these checks removed or statically decided, then and that works. That would prove that this code is any good, but I never quite managed to integrate this in any good way, shape or form with iterator with the rest of the value tracing. So basically, it wasn't really all that good. And I had a new idea recently. And that new idea recently got me to do things slightly different. And the difference being that this iterator here is actually in the value tracing, it is analyzed and it has a type shape. And it sees its argument is a tuple. So this is actually def f1. It's being reformulated to it's actually in the developer manual. Reformulation. No, user manual. Mono-spaced font. Come on. Spelling suggestions. Okay, maybe it just doesn't know it. With state. Okay, so outline. So iterators in place, assignment, unpacking assignments. Yeah, this is what I was going to write. So actually, the iterated value is being built, an iterator is created, then unpacks are being done, and then the result is checked. So if we go here, so temp iter equals iter 1.2, x equals next, temp iter. That's very simplified because I think, yeah, it's actually first being assigned to temporary values. So the assignments do not take effect before the checking passes. So this actually means it's even worse to have this check because you get to have these temporaries and only later assign to these temporaries. And then you recreate a new iterator and do it again. That's very inefficient. But as you can see, maybe you are unpacking, maybe you're not unpacking. T is not unpacked. And different values. And the temporaries are actually released, which is not shown here. Well, it's complicated enough already. But yeah, so actually an unpacking is a terribly complex thing where actually the unpack check try next temp iter accept stop iteration pass. That's actually the good one. Else raise too many values. Is it value error? I don't know. Type error, value error, I don't care. But that's actually what's happening, and what the iterator tracing was doing. This was like putting it here to 0, or 1, 2, then eliminating this one, knowing it will raise stop iteration, the unpack check, and so on. So that's one way of doing it. And what I thought is I will go another route, and that is I would recognize that instead the iterator recreation. So suppose I have this, and let's just do this as unpack check. It's also a dedicated node. Yeah, and it knows 2 is for the error message. So it says I expected 2 values, but I have more. Okay, so what have we got here? So we put this here, and this one will now put a temp iterated is 1, 2. It will put itself like this. So nothing happened except we made an assignment that would be value propagated. And then we put temp iteration count to 0. And yeah, and we take note like marked as propagating. And now these ones will replace themselves with x equals temp iter temp iteration count. And temp iteration count should increase. And the same happens for y. And now this is based on the fact that the iterated has value random access, like tuples, lists, strings, bytes, byte arrays. Many values have dictionary sets do not. So we'll not optimize those, but as you may be aware, for those it's probably not even a good idea. And unpackings for them are really not happening. And then you do unpacking iterated check, temp iterated, and yeah. Actually, this works like this. Takes the length, because it also has a length. And that's here something that will be optimized statically, potentially, and the value tracing should actually, in the next step, do it like this: def f3. I think the actual count doesn't matter, but we can work off length of the actual length. So what's going to happen in the next step is that the iteration count becomes forward propagated. So actually we have is here. And the len is also statically determined. And as you can see, this one becomes optimized away. And the next step is like this. Equals 1, equals 2. The iterator is being removed because it has that has happened before. I think it should already temp iterated. This one is gone. And now this one is also eliminated. This one is eliminated. And yeah, I did the return. So return x plus y. So in the next step, it's return 3. So, and that's actually working with my branch, except that I do not do the increasing of the iteration count yet. And we will get to that hopefully today. And okay, so where are we? Where do we start showing it? Okay, did some fairly innocent changes. This is in preparation of optimizing things better. Instead of creating a subscript lookup with a constant subscript of 0, that's very similar. So far, even if it's an index lookup like we are going to use here, it will still store it as an integer constant value and optimize it and give itself a hard time optimizing. So I created at least a factory function that allows us to do this kind of change. And there's a couple of spots where existing reformulations had this, so I replaced this. And where is it going to be? In subscript nodes. So that's an innocent change by itself, just a cleanup. And as you can see, this one just creates the constant in here. So it's hidden here, but I added a to-do, and maybe I can specialize then the subscript lookup. Doesn't do it from here. And make it have a case where the subscript is a child or is not a child, but a constant value. This one is also here something that's for our old iterator tracing. Anyway, attempts. So that's part of that. And the next nodes, maybe let's look at the variable reference nodes. Yeah, let's go here. So as you can see, this is now importing make expression subscript lookup, because actually it doesn't know the index itself. It's using the temporary variable. So we do not have to be any clever here. So we just use this variable here and put it there, and we're good. So that's, oh wait, temp iterated should also be here, right? So we just can replace this guy here, if it's marked for as propagated, with an index lookup, and we know the variable, and that's all it takes of us here. So that's just a minor, that's just cleanups. I changed something in the next interface here. I think it was may not raise, and then was used in a Boolean sense. But I think this one is going away anyway. So, but let's check it out here. So that's so next. So an expression is computed with next. That means we are here. So we have this expression, which is a temporary variable reference to an iterator. And next is being called on it, and the next node actually has an implementation that it asks my child. My child will know better what next does than I do, so I'll just pass it on. If it hasn't any influence on me, you can replace myself with, for example, an exception, or like it's done here with a subscript lookup. So what's going on here is we find the iteration source node. So a variable trace means our current state of a variable in the tracing should be, well, there is an assignment of temp iter from an iterator, okay? And if there were other assignments, or if this value escaped, somehow got corrupted, potentially corrupted by being used in some fashion that we do not know things about it anymore, this will return none. Especially, of course, if it's not an iterator. Then we're checking here for something special. I created also specialized variable assignment nodes. For propagation, it's much nicer if you specialize the optimization for what the source actually can be. And so we can check here, is this an assignment of a variable iterator? And then this here indicates the setting of this variable, as we will see, is like, what is the iterated variable? If it's not there, it's not marked. So actually this is like by setting temp temp iterated variable. Obviously, obviously these are unique names, and that's a variable object, and the variable object has the name and so on. And then I make a subscription lookup on the expression. The expression is the iterated variable, and the index, the subscript, is the count variable. And there we are. We tell the next node, replace yourself. You are being replaced with that. And because we were actually here tasked also to produce something that has annotated its effects on we were supposed to annotate the impact of a node, and so this actually evaluates this node and tells it, look, you have been referenced, and I actually had a lot of bugs with variables not being referenced. In the next pass, then if the variable is not referenced, its assignment gets removed, and then the reference goes haywire, and it's actually pretty bad. And yeah, so there we go. Not exactly hard to do. Then, of course, if that didn't happen, the iterated constant escapes. So imagine this wasn't a constant, but there were some variables in there, and next would assign it somewhere or use it somewhere. We wouldn't know what happened to it, so maybe it gets changed. So it's actually annotating a loss of information. And this one is also new. A value can indicate if it has an effect, if next has side effects. That means, is this a class implementing next is different from a tuple iterator. A tuple iterator causing next, there's no control flow escape. What we're asking here. In case of a control flow escape, you want to all closure variables, all global variables, everything could have changed. You don't know what code is running. That's pretty bad. And if we didn't do that, yeah, what we're pointing to escaped. This variable cannot be trusted anymore. Anything could have run. So it's very, very important to avoid this control flow escape, because it invalidates all the variables, which is it's pretty rough. And actually, yeah, it only escapes the our content, but the control flow escape can also corrupt all variables that are shared with other functions and globals. Not good. So this is something in the basis. Well, the next interface, I think this one is unfinished. I did not ultimately decide on what the default implementation is. So I think compute expression next is not good. And this one is not actually doing anything yet. That's the task of overloads, and probably need to be overloads. And everything has side effects right now, which is also not good. So actually, there is a function that I have prepared, and it's actually if I could implement it right now. And the built-in type shapes now have functions to indicate. So every type shape. So maybe I need to reiterate what a type shape is. A type shape indicates traits a type has. So a tuple iterator iterates over a tuple, and for example, every iterator, or let's say it's not a number, when apps will not work, int will not work, long will not work, module will not work. Yeah. So many indications what it is, and this one here, it has an iter. It is an iterator shape. The iterated shape could be known or not. This is for overload. And yeah, it has a next and so on. And the next code, usually for the built-in ones, doesn't have any impact. So as you can see, this is not being used yet. But actually, I can put it to use in node basis right now. Side if, or was it expression basis? We have side effects. Let me go back to the diff. Node basis. We looked at node base, expression basis here. And content escapes may have side effects. Yeah, and we can do something that you can see how it's done for len. It's actually now, we can ask ourselves what type shape do we have, and has it code attached to next. And can I call this no matter what? It doesn't exist, I think. Yeah, shape iterator has this. Actually, I think to be safe, this should be in shape base. Next. None meaning we don't know. False means we know that's not the case, and true means we know it's the case. And yeah. And now, expression basis, we can do not being static. Now we can actually if next may execute code. Okay, so one step closer. Before, this would just actually have disabled all the code and pretended as a control flow escape. Now for dictionaries, it will know that next doesn't do code, does it? Has slot next code, because every it's a dictionary iterators. This one here is standard shapes, t shape dict. go there. Shape type dict, and it has container mutable mix in. And the T-shaped dict iterator has this and has by proxy. But as you can see, it doesn't have that. And actually, I can I do it like this? Add words. I never know. Yeah, we'll do this eventually. And okay, so that's the infrastructure for annotating these things. Sometimes I'm not entirely optimized with these. And I was looking at the diff in the Windows one. So yeah, let's ignore this. I think I want this Boolean to go away, and we'll say on expression, because next usually I should use here the next may have side effects. Is this being used for may have side effects? Next. It's only used in one spot, but the generic spot could also use it. So if self has a side effect next, if self may have side effect next, only in this case we want to do that. That's also immediately an optimization, even if the iterator tracing is not done. I think this one. Wait, what? Where are we in iter 1? I think, yeah, iter 1 has a value. Value. You see? Huh? This one does it. This is a base one. This is an overload. So on an iterator directly, we don't know it unless we know. So this is this would only happen if an iterator itself got a next as a value. And of course, only if that has an effect. Yeah, that's not the most important case, but it's still something that could and was implemented. Yes, and in variable reference node, we are kind of doing it already. Here we can do it. So now what's value here? Itself. We are being visited like this, which actually we could, yeah. And why is it doing that? This is other versions, I think. Do that away. Okay. So really minor stuff, but let's not commit that. And what do we have here? Yes, it's good. What we wanted. And what want it. Obviously, sometimes some iterators, for example, may overload this, may have next code. If next code, iterator nodes may remember that, optimize that, these kind of things, but it's not a costly thing. So more iterator work. Okay, but that's not actually the core of things. So if next has code or not, it's about eliminating next. Yeah, as we know. So standard shapes. Yeah, we looked at all of this actually by now. And so assigning is actually what's left to look at. So I did some specialization here. Which class is this? It says above, I think. No. That's a very basic assignment. I think this one goes away. That's why there is a huge diff. Is that what's happening? These are all just cleanups to how these, I have on factory already a change that cleans up optimizations. Where is the beef of it? Yeah, this is now a new function. So these things can be reused. It was copied a bit. And here we have added temp iterated value. Yeah, I already added this node. So assigning to an iterator gets specialized. And here, when an assignment statement is created, it does this. And here, considered in specialization, when a generic assignment discovers that it has become an iterator, it will replace itself with just that. So nothing really dramatic happening. Should it not copy I think the variable trace information might make sense to copy that. I need to think of that. Probably eventually some assignment statement will not optimize very good, or take more passes, one to build the trace and find it again and so on. Could create bugs actually. Yeah, I think that's a small problem, but let me add a to-do. When doing these class switches, we need to copy self variable trace as well. Because I think it got computed already. Consider specialization is being called and a place at the end. So this one has happened, and this information will get lost when we get replaced. That's not good. Yeah, but didn't show itself much in bugs yet. Okay, so let's go back to here. So what is this? Basically, it has a memory of what shape it is, and later updates that. Or does it? Yes. And this is the important bit here. So if we didn't do it already, and we have this one here, and that's one of the changes that I have. It's only this is I think it's being used in Python 3. This should be done for iter1. So this expression for unpack is the one that we see being used, but normal iterator should just be treated the same. And I think, isn't it here? Yeah, it's actually Python 3. Normally this one is being used. So I was developing against this, but it's actually, and I think that's why my code is not being done for Python 2 yet. And this one is a victim. So wait, where was I? I wanted to go to iterator. Yeah. I wanted to go to its expression built in iter1 because they are base class. They have a base class, and yep. And this one I added with the intent to use it, and I can recognize it from here. And the special unpack just changes, I think, what runtime error will be given. So if the result is an exception of type error built-in exception, then it will just make a cannot unpack non-iterable. We'll use a different text. It's one way in which you can reuse this code from this guy here, which gets this from the child. And then the child would create this exception. But during unpacking, actually, what Python does is like it does this check at runtime. Which check? It actually does this at runtime. And if an exception occurs and it's a type error, I should be able to find it in the C code. Yeah, here we are. So it's actually, yeah. Unpack iterator. No, I'm having different code here. This is a static error and cannot unpack. Yeah, a bunch of effort. But this is all just unimportant stuff. But using the unpack also made my code built in iter1. There's an iter with 2 arguments. That's why it's iter2. Not there's why it's iter1. So if it's if it's not being used on the outside, that's what all optimization does. Like closure variables, you don't know if the next would happen on the variable in another function. No, we're not trusting that to happen correctly. Although now that I think of it, maybe it could work. It could be made to work, but it's not important. And if it has an assignment, if it is an assignment actually and not a merge, then we actually found ourselves. Then we check if it has index lookup, the iterator value. So source is our assignment source. The subnode value is the iterated value. And if that type shape has index lookup, means like, for example, tuple in our case, then we allocate a temp scopes. So that's needed to keep the variables non-colliding. And then we allocate an iterated value variable and create a reference to the iterated. The iterated value itself is our is the iterated value, and then we assign it, create an assignment variable statement. We create the count variable. Why is this? That's rather strange, is it? Black is doing funny things. Or I had braces. Really? Black insists on that. I use black because I don't discuss source layout. But that seems rather unnecessary. It avoids, I guess my problem here is the deep nesting. That's, yeah, we have like a very deep indentation already, and it tries to avoid the line length. That's why it's so bad. Maybe all of this could be in a function and should be in a function. Anyway, yeah, probably we should do that. Now, this builds these assignment statements. So an assignment statement that assigns the iteration count, the iterated value, and ourselves. And this just takes this just says make a statement sequence to replace ourselves, and then we say enabling indexing of the iterator. Didn't have like a very good message yet, but after this, when it looks for us and the parent of this iterator node, then it will find the self iterated count here in variable ref nodes where we saw the this happening. So that's basically all it takes, and now only the check remains. I actually forget where the check lives. It's a special unpack check something. Special unpack check from iterated. That's the new one. So still need both. So this is the old node. It has the iterator and the variable, a static variable from the source code, essentially an integer compared to 2, and it will like try to do thing. Actually, I solved that to do. That's not a to do anymore. So if it's a temporary variable ref, what we're working on, which very well, probably almost always is, then we look at the iteration node, find again if this is the case where it is replacing us, asking us to replace it, and then we create a new node that is a different one, and we ask that node to directly compute itself. Otherwise, we say, well, anything could happen, I don't know. Previously, there was code here that tried to do this length check based, but now we're replacing ourselves here rather unconditionally in case of things where we do the length check. This is a small helper function which basically invokes len and creates a temporary variable reference on the variable we were told to use, and creates this node. And this one here just does half is one child, which is a length value, and the length value is then being asked to compute itself again. So maybe we couldn't compute len of the iterated value at some time. Maybe it only gets known later. But at some point, maybe len is being replaced with a compile time constant. And that would be very likely an integer. And therefore, we can just ask it and check if it's sufficient. Or we make an exception race replacement. One of these that you can warn yourself about. And annotate, of course, that an exception may have raised. In the else case, of course, an exception may raise. Yeah, maybe the len code also set arbitrary code can run already. Shouldn't the len code, should I? Actually, I think the len is the one that can raise the exception. I don't. No, it's my task to create an exception at runtime. Yeah, I have to say, so it always says base exception. So the exception tracing is not good. Basically, it's a Boolean and it always says base exception and never checks anything, although sometimes I will annotate that it's actually a type error. But makes no difference currently. Getting that right one day will be a huge task. So these are the 3 bits. And with that, I can try and run it. You can run mini unpacking opt. What? Ooh, last trace. Variable trace is expression. Let me undo this for now. Not sure. It's actually that. So right now I managed to limit myself to iteration, and yeah, unfortunately I can also put here verbose. And here we see a lot of things it's being doing. Actually, I have too many functions right now. Let me do mini unpacking opt. Let me comment all of this out because I do not want to see toggle line comment. I didn't use this a lot. Wait, where am I? Okay, that's going to, maybe that's why it had iters and so on, and maybe unhealthy ones where my code is being too optimistic. So let's read through all of this. So using file original value, because in acceleration mode, under file is not runtime determined. It can decide that, okay, I built this as a file reference, but now. That means that the assignment source is now compile time constant. I think I would like the variable name in that output. Assignment source of %s self variable self get variable name. I think that's going to work. So let's improve this. Yep. Quoting. Okay. Maybe I put it into text file. So file is now a compile time constant. Okay. Then a scope of a tried block has preceded leading statements. Yeah, I think this one is pretty bad. So it outputs the dump of statements. I never read those, so Then an uninitialized temp variable is not released. Yeah, it's finding branches in which the unpack element 1 and 2 wouldn't be set and needs no release. Okay. Enabling indexing of iterator for line 2. So line 2 obviously being this one here. Yeah. But yeah, we do not have a real name for this part here. So basically enabling indexing. Maybe we say enabling indexing of iterator for forward propagation. I don't know. It's not very readable. So iterated next converted to value access. So where are we? So we are in a variable ref node. Basically, we are probably an assignment, but we don't know. Iterator next. Iterator next of indexable iterable converted to value access. Iterable, yeah. So it's happening 2 times. The len was also immediately predicted. Len result of variable. Actually, we could. No, I don't have a name for the unpacking. So I could output this variable name. I could output the variable names. Yeah, maybe I should, because they are going to be used here and there. Enabling indexing of iterator. Through %s. Oh, let's put it like this. How about, where's the variables? Self variable. Temp iteration count variable. Let's see what this looks like. We try to get readable. Because what's bound to happen is like an endless stream of, I need to ask a variable. I forgot get name or get variable name. Get name. Because this is a lot of code. What I'm doing is I'm returning a lambda, so in non-debug mode, it won't take the time to actually look up these names and build the string and so on. And only do this, so it's pretty long. Well, yeah. So iterator access 1. Yeah. Okay. Iterator next converted to value access. Yeah, why not say which one it is? It's actually the same thing. Maybe I make it a function. How about get iteration disk. How about with quotes immediately? Yeah, why not? Okay. So now we get the description. And it's only one value, then let's not have a tuple. And hooray, maybe. Okay, and we were working with this converted to value access. Iterator next converted to %s, %, where's the owner? I think it deserves a name, doesn't it? Should I do it one time sooner? I don't like it to assign a name and then test it if it is what the name suggests. So, but we can stop using the node here. It's parent. It's pretty ugly, isn't it? It's not so much about it being slow. It's more aesthetics. Okay, maybe it's good now. And we want to make this a lambda as well. And look at the output. The warning you see here is, I see it now all the time because of my tests. It's pretty normal. I can do no follow imports. And I don't have it anymore. But yeah. Okay, so now it's more clear. Kind of. Yeah, but this name is being used later on. So predicted len result of variable. Is that something I will find? Yeah. So actually here you see another case. Yeah, compute expression len. So if we have a very good understanding of the assignment, then we can predict the len. I think I recall that this is a bit limiting. Actually, the length could be optimized for merge traces maybe as well. But here we get the actual node, its shape, we check if it can have length and so on. We do pretty neat tricks, but it's not being done for like if A equals this and that, and maybe both have a length of 3. That's not dealt with. But why doesn't it say the variable name of variable %s self get variable name, huh? Okay. More readable, huh? Now we know it's the iterated value length. So iterator check changed to iterated size check. Yeah, here we are losing it. Okay, the length was iterator check. Which iterator are we checking? Iterator check changed. Do we know anything more here? I think we may not. We know which iterator it is. So lambda iterator check off. Cause I think, yeah, here the same thing is happening as in the expression. So let me see the diffs. Let's use this as a pattern. So what's going on here? Iterator is sign node, and now I want to use iterator is sign node in more places. And I know that it's an iterator assignment, but now I wouldn't use I only use one variable here, and I think I should only mention it. Iterator check change to iterated size check using %s, and it's is this a variable? Yeah. Yeah. Okay. It's even running, yeah. So iterator check to now we're here. And determined iteration length check to be always true. Then I don't know which one it is. Because that's really only 2 numbers. The len got replaced with 3. To be always true. Yeah, come on. Let's say which numbers are the same. That we can do. I think less than is extremely unlikely. But maybe we find that some code gets removed soon. Oh wait, -t. Not enough. Hold on. Okay. Could have been a comma. Okay. 2 is being used. And now we unpack elements. These temp variables are not used in more cases. So count gets propagated. The values get the access value, the iterated value, and the iterated count gets propagated. And subscript with constant value, predicted constant result. Can't really output the constant result here, but that's where our indexing of 1 and 2 is happening. Problem being that the iteration count is not being increased. So this is 2 times index 0, and therefore we have the wrong output in the end. So assignment source is now a compile time constant. Is it? Tuple unpack element 1. I don't know. It is a. Did it keep the name? Yeah, it kept the name, I think. Yeah, assignment statements don't. Yeah, this is, I think, the assignment statement. These two belong together. They are the assignment statements for X temporary variable, Y temporary variable. Then lots of exception handlers. I meant to change this. Useless try all handlers removed is not what it does. I've seen this yesterday as well. So actually what this does is in the optimization of a try statement in the general case has a break handler, a continue handler, return handler, accept handler. If they all are none and the try block may not raise, or it's just a re-raise, or the exception handler is a re-raise, and so on. All handlers, I would say, became empty. It's actually, yeah, more precise here. And useless exception handlers, useless tries, then these iteration counts and so on. What's happening is if you assign and it gets removed, it's being replaced with a deletion because it's not clever enough to know immediately right away that it can be entirely erased. But I would just say if it had a value, now it doesn't anymore. So the previous value gets released, but actually these didn't have previous values. So yeah, maybe it could get smarter about those, but it doesn't matter much. They can happen later as well. And then the assignments from the elements get propagated, and again, a value gets propagated to X. X is now compile time constant. Y is now compile time constant. They do not have an impact here as well. The assignment for X and Y get propagated into the return statement on line 4. And add with constant argument, predicted constant, the return value is constant. A frame object is no more needed because no exception can occur. No frame will be had. X and Y are no more released, last try handler, and so on. And the local variables do cease to exist. So that's a pretty granular walkthrough of what's happening, and except for here, I think it's all about this one line of code. But we are very close to having that work. Now, what's missing and where I couldn't wrap my head around yet is how to do this in a sane fashion. So what I did with the variable assign nodes was I added, I can stage my, in this way I can do it. Output, I do not delete it, do not need it. Yeah, these just refine outputs. So it becomes more readable. If multiple of these are happening concurrently, otherwise it will be impossible to debug. So improved debug outputs. Okay, debug outputs, very nice. Yeah, so what I did, because the statement, there's one problem here. And this is if I did not have this iterated assignment. Iterator. This guy here. Statement assign. It's not in this file. It's here. I created a statement that has a specialization, that its argument is an iterator, and then I do not do all the things. I just care for the iteration, but I do not care for, let's say, variables, things that only make sense with variables and constants and so on. And this allowed me to replace myself with statements. And it's actually pretty strict distinction between statements and expressions. Expressions have values and are the building blocks, can be the building blocks of statements. So the assignment has a source, and that's a node. And as you can see here, assigning 0 to the count variable, there is still a constant node. And this can be used, for example, this node when value propagating it to an expression. So now what's happening with the here with the iterator nodes, was it this one? No, variable ref nodes. So the variable expression replaces itself with a subscript lookup when next is being done on it. Okay, very well, but we would have to also change this. And there are side effect nodes here. But make statement only nodes. I think side effects are again expressions. And yeah, there's no good way to have a statement as a side effect. That's basically, and it's not a clean way to do it. So the solution in variable assign nodes was to replace a statement with a statement sequence. So that will just replace itself with 3 statements. And it's actually not, is it so? Am I doing myself a favor with returning a statement sequence? Yeah. In statement sequences, statement sequence, statement nodes. It's not in its own thing. compute statements sequence. Here it's going over the statements. And if it's a sequence, it asks itself and so on. And if new statement. So this is where we return from. And if it's not none, then we check if it's a statement sequence and then we extend it. Otherwise, we append it. I'm wondering why I am building a statement sequence. Why do I not allow myself to just be a tuple? Because I am throwing away. At least if statement is not if it's not the last one, but the new statement. Am I using new statement again? No, I'm not using new statement ever again. It's just not sure if it can be a statement frame, but if it's only a statement sequence, it's throwing that away. So not sure. Maybe if I do it like type. Guess I wanted to avoid that kind of check, but I have to check it. Actually, type new statement is tuple. And now I could just not. Yeah, because it's I need to make up here something. But okay, it's not used in many cases. What's going on here? Statements. So print is trying to replace itself here. And I could just make the statements. Probably no longer pilot clean after this. Let's remove that then. And yeah, I even have to cheat with the parent. Wait. No. That's not. Does this make them my parent? By creating a statement sequence, I enforce the parent-child. Yeah. It does something. But then I do go over new statements and doesn't seem to matter much that I don't have a proper parent. The old statements are finalized. And then I set child new statements. Yeah, and that's setting the child. So no, that's okay. Print nodes should work. That's for Python 3 actually, isn't it? Or 2. So I can get away of this. Oh, no, here I use it to when I compute it. And I probably usually compute it. And it's probably actually a bug if this one doesn't do it. So no, go away. No, we don't do that because it makes it easy to get something wrong that's important. Like being computed actually is something. So these are statement only expression. Have we? I think we are fully evaluated. So we evaluated this and none and so on. And in the end, we said value will raise an exception. Oh, the destination is none. And if it is side effects, I'm promoting these to the outside. Yeah, doesn't matter. This is correct, actually. Oh, wait. That was a bad idea. Okay, happens. So, okay, I cannot make this any less complex. So side effects, variable assign nodes. Yeah, okay. So what I was trying to get to is like, I might have to have a statement that is an assignment from a iteration next. So actually, and this is solely for the purpose of it making the determination of what next is doing rather than the node itself. So let me copy this thing and call it variable statement variable next. And next, we're probably not having. Do we have type shape? Maybe, maybe not. I don't think so. We're not in Iterator. We don't have these. We don't need that overload. This doesn't apply. And now we can compute the next and make the next check the parenthood, or yeah, maybe we don't do this. So maybe in a different way, built in next nodes. So the next one asks its value for the next. And the variable reference, yeah, it's a next of a variable. We are actually mostly what we are going to have is like we are going to be a bit like the next. We are going to inline the next functionality into a variable assignment. So we are like our subnode variable source, yeah, is not going to be the next node. It is going to be yeah. I need to make a break. So let me try and get coffee break. Cameras off. Screen capture can remain on. Yeah. I will be back in 10 minutes. back. Let me just briefly enable the audio on YouTube. Just briefly. Yeah. Sorry about that, but my headset has had a tendency in the past to just disable and never come back. Let me check. No. Okay. Yes. And never come back, huh? Okay. We go here. Ooh. So, yeah. Let me re-enable the cam. Okay. Ah, fantastic. Sorry. Okay. So what I want this to be is like a combination of a next. And then what I'm going to do is like the iterator, the free iterator node. It's going to mark an assignment as escaped. And when it's marked as escaped, we are going to disable the iterator propagation. So basically what I'm trying to say is there's another function def g ist gleich iter 1, 2. My iter. So you write this code and you write x equals next my iter. And then you do, I don't know, outside call my iter. Or you do copy iter equals my iter. Y is, let's do 3. Copy iter next. Z equals my iter. But what am I talking about? My iter. So the next or next. How can this be disturbed? So when this happens, copy it f my iter. I want to stop here with that sort of optimization. And in fact, because I don't know how to do this without doing that, I will abandon the whole replacement. That's okay. That's called escaping. Now, if I do next my iter plus next my iter, it's going to work. But it's not an assignment, and thereby causing difficulties for the tracking of the variable. I wonder if I should not make a next that is also an assignment. on increase. But for variable tracing, I think it's expecting assigned nodes. And then for dropping value propagation and so on, they really, really want to be separate things. The only way I can see this happening is like if this plus was working on temporary variables. So I'm going to skip doing that and only do that and disallow it here. Was that allow, disallow, and disallow that. Although that may actually happen, but it's still a statement. Yeah, this is where I'm stuck. How do I establish this in the existing structure? And is there really no expression that has... I forgot something. Yes. I forgot an important solution. It's been done already. It's called outline. Outlines are a strange thing, but yeah, they are essentially what lambda functions are, except they allow a full function body with a return statement. So expression outline body. Yeah, reformulation. Here it's being used, for example, in exactly assignment expressions. Yep, that's an example where something ends up in being an expression, but becomes a body. So you have a bunch of with a really nice return statement. That's the actual expression. So yeah, I'm being stupid. So the whole problem that I am visioning here does not exist, really, and I could have done it without specializing the iterator assignment. Oh, yeah, but that was still good. But this one is useless. And yeah, I just need to create an outline body. And an outline reformulation. Where is my developer manual? Maybe I use the web version, huh? Design description. Is this reformulations? Yeah. Turing optimization. No, that's actually to make things simpler. But they may actually complex assignments. Becomes this and so on. Oh, the free 8 assignment expressions. Are they even here? Maybe they should be there. So what's it called? The assignment expression, huh? So unpacking assignments. I think, where do we put it? Print statements, match statements. I put these more specific ones down there. Match statements. Let's put here. Wait. That's sort of like it, but not really. Assignment expressions. So small detour, but just to get a refresher on how to do this and maybe how to talk about is if x something something. Okay. In Python 3.8 or higher, the match statements don't say. It's pretty rough, huh? In Python 3.10 or higher, you can write things like this. I'm not even sure. Yeah. I think that's pretty much what it does. But it's pretty incomplete. Match statements, I guess, need to be better documented at some point, but they are not even complete. So in Python 3.8 or higher, you can assign inside expressions. This is the same as. And now here we come. If also it does an assignment, huh? Does it do an assignment here? Yeah. I can do everything. It has access to the same locals. It is, yeah. It makes an assignment statement to a temporary variable. So we say non-local, huh? Non-local def outline func non-local x equals cont return x if outline func. Do something. Doesn't exist with that name, and it is not really taking closure variables. It just shares the execution context. Okay, non-local. It hates that for spell checking. But it's an actual deficit of a spell checker where it does it on keywords. It's maybe asked too much that I would know that this should be spell checked according to Python. Does it? here it knows it's a keyword. Okay. That, of course, is what it takes. Could be done with the iter creation just as well. If possible, these functions will get optimized and they will be visited just the same. So when the expression gets visited, this is being treated as a statement, and then the return value gets assigned to here. No big thing really. And what we are going to do is when we use this outline function, we are allowed statements, assignments in expressions. For optimization, they of course pose challenge to be removed. Error happens when it becomes only a turn statement. But they do not cause much difficulty for code generation since they are transparent. It's just it's not difficult for the C. It's just a go-to with a return value back to where it's supposed to be assigned, and there's only one. And this will be optimized on the C level mostly. No difficulty at all. So this is the tool that we're going to use. And actually, in our case, the non-optimizing next. Here, this part here. So this will be put into an outline. So let me toggle these back in. Toggle line comment. We toggle these back in. So def outline 1. Let's call it result. In the outline, they share it. It's a unique value, but for clarity, and I think I will have to describe this new style iterator optimization in the developer manual clearly. But now x equals outline 1. And okay, sort of makes it clear that this is local. We increase it afterwards. For the last one, this is going to be optimized away. In which case, it is going to be optimized into that, and the outline, the second outline, the last outline is going to be removed. So I'm not going to repeat it now for the second element, or am I? It's actually the same, isn't it? It's the same outline. Yeah, that's a pity. They do not get reused. I could make a helper function then it would get reused, but then it's not inlined and not optimized. So okay. And this is what we have to produce. And the place we're going to do that is in the next of a variable reference. Variable reference node. Here we are. I think if I do this, says 2, we want to have it free. And then it's perfectly tested and fine. So this is the, it's not the result. It's like iterator lookup. Dann we need to allocate an iterator. We do not have. Actually, what makes sense to know the scope from the iterator assign node. Because now I'm going to do like self get provider. And the temp scope. Why is it not here? Who starts it? The iterator taking of here. We started here. Temp scope. Really? No. We find the variables in the class with the iterator here. Find it from here. Guess I could move it into the iterator taking. If the iterator taking is capable of annotating itself as an outline, it's going to be difficult. No, let's leave it like this. But where's the temp scope here? And why do I not? So I have this, and I need to remember it so I can reuse it, because I think the temp variable doesn't. You will not remember it. It's just building a name based on it, and we need to remember it. So self temp scope. Just a second. Need to add the attribute. Actually, could use self temp scope equals none for testing. So it doesn't expose or depend on the name so much. Temp scope. Now we can next. We need a variable name for the result. Self allocate. So the name is going to be next value. Do not want to use the same name for all of them. Do I? I think I'm doing it. Is this caching? It doesn't allow it. So it's actually not even allowed. So it would crash on me, I guess. So should it's getting released in the outline, I think, if I take care. So probably I will just have the assign node for use when the next is replaced. Next value. Okay, and we use iteration next variable. And we have yet another variable. Okay. And we need to assign to that. So actually make statement, or make variables, blah, blah, blah. What's it called here? Make assign. It's a factory. Make statement assign variable. This reference variable nodes? Maybe. Variable ref nodes. Yes, it will. Yeah, these factory functions maybe need to be living separately. From point variable assign nodes import make statement variable. So what is it going to be? What am I doing? Okay, hold on. Oh, nice. Yeah, I need to write an email. Hold on. Small break. Screen capture, no. No me. Just a few minutes. Okay, so nothing too important, but I am giving chess training, but not in school holidays, and I needed to clarify that. It's my other hobby, chess. I am not as good as I want. I think everybody has like the tendency is that you reach a level and then you are forever unhappy about not being as good as you want to be. Okay, make statement variable. Why is it not strange how it does variable assign no? Yeah. Okay. So the source is going to be this one. So from here, source equals this one. So, but source is not everything, is it? The variable we're talking about is this next variable. Is this already? No. Yeah, but the variable is only an option. It's not, but and then it will. Yeah. Okay. No. Variable equals temp iterated next. Or what was it? Yeah, the iterator variable has this iteration next variable. Okay. What else do we have to provide? We have to provide a variable as source. We're done. We do not know a version, and we don't have to. So that is one statement. I make these super indentations, huh? I really will. Yeah. How about def replace make iter it's a bad name. Let's move this here. Let's use this as an argument. And turn self make iteration replacement. Or let's call it iteration next. Replacement node. Okay. And this moves to that. Yeah. Slightly better. And we have one statement. And the next one is the assignment statement that increases the count variable. So, this is for the iteration count variable. And binary operation nodes. I don't know if I have any helpers. Operator nodes. Operator nodes. Something add. Binary add. Is anything? Nobody's creating those. Really? Nobody's creating these. Why? Do I never have to add one, huh? Really? That's a first. I'm hoping that someday there will be like an operation that just does constant adds and increments and so on. But not now. So the source is actually the count variable. But from expression, there is no factory for that. There is in place, binary in place. That's maybe what I'm looking for. Yeah. And who's doing that? A few do that. Okay, so in place to temp, that's for assignment, isn't it? Binary in place. Yeah, for in place assignments, but it's still, it's a bit. Yeah, let's use that. Make expression, because it's an in place add. It definitely is. On this one. So left is this. The right is make constant ref node constant equals 1. Source ref equals source ref. Why is it not completing anymore? So we are making in place here, left, right, source ref. I have a suspect that it could not be localized. Not sure if I will get a error from that. And self source ref is probably what we are using here. And okay, so we assign to the count variable +1. And binary in place wants an operator. And I guess EAD. Yes. Iteration source node. What? Where is it? Iteration source node? I thought I had iteration assign node. Yeah, that's okay. Keyword arguments to rescue. And the trace collection. Okay. Maybe I remove this value from this false value. Now, because it's something I need to do. And trace collection is not defined. Okay, I'm not getting there then. Okay, but I will need trace collection. Getting there. So we have our generic variable assignments. Why is it generic? Because in place is not specialized and subscript is not specialized. Oh, I think subscripts ought to be specialized. Assignments from subscript lookup. Happen a lot. But that's just memory optimization at this point. Okay. Did I remove the assert? Yeah. So this is actually the body of the function. We don't take any arguments. We just assign to the next variables, and we need to return. Make return. Make return. Make statement return. Make statement return. Here's what it is, and it optimizes non-return compile time. I go through a factory. So here are also specializations galore, and make statement return with an expression is what we're going to do, and it's importing from return nodes. Okay. Yet again. And the expression is a variable reference of this guy. Yet another one. No, of this guy. Actually, the one we. No. here. So the next variable, we need to reference it. And let's copy a variable reference. Change the variable. This is the function body. It's the most painful programming. You program by creating these nodes. There's no dependency between those. But I think I will separate these nodes from the factory functions at one point. Because this function could work on, so the nodes and the factories should be separate, and maybe the factory is then more often node making helpers. I don't know, but I've not done it like this. So is the return statement here? Yes. Oh, it doesn't say much about itself. Okay, so expression outline body is something we searched before. Let's find a nice example. Here they are defined. They have a body, which is essentially just a bunch of statements, a statement sequence actually. And here is a case of another one built. It builds a statement sequence and releases probably a temp variable. I'm not releasing anything yet. I never dealt. But when I have my state, so I create the outline body first thing. Does it have to be a unique name? I actually forget, but I guess it should. It should probably be a unique name, and I said I cannot reuse them. Oh, whoa. Right. Then names maybe not used for anything but temporary variables that I don't do. All right, that's a problem sleeping. Name, next, value, accessor. So provider is trace collection get owner. It needs that in case it needs to allocate something, but it doesn't matter. And same source reference, expression outline body. I need to import it. Because of import sorting, I don't really have to care much about where I put imports. iSort is such a blessing. And now what happens? So the outline body gets set body called. Doesn't that have set body? child body. Seems wrong. Does it with itself too? It's wrong. But where would it get it from? Probably, I think I abandoned these setters. So set child body, okay, I can do it. Yeah, the final is empty. And I'm thinking right now what it would have to be. Is there anything I need to delete? Can this assignment go wrong? No. I may not have anything to delete because when the subscript lookup goes wrong, I have not assigned anything yet. Then I did it, but this +1 will not raise, and this cannot raise because this is assigned. So it's actually I can do outline body. I think the outline body is the value that, yeah, it's the value that replaces the thing. Okay, make statement sequence from statement. So I'm not doing that, but make statement sequence. From statements, I think a thing. It's coming from tree helpers. Tree helpers lives where? From Nuitka nodes tree help us import. Only need statements, merges them, and so on. I'll try finally. It's just doing a harmless assignment statement on the side. Insertion. What? Oh, I actually have it still. So why did I add this? Immutable, what? Ah, okay, yeah. I was hunting a bug and this is of course allowed to happen. Wow. Look at this. That's working. Now the question is, how good is it working? But for the test case that I was aiming for, it is working. Let me check with Python 2.7. Yeah, I don't have it here. I need to copy over my bash.c. What? Oh, non-local. Yes. Mini. I guess I want to toggle this off again. I'm much more used to having my frequent commands on top. So there we are. That seems that's a good idea. That was just a detour, I guess. There are cases where we don't want to do it. So I guess I remove this part. That is just garbage. I need to search for more. I did at some point. This is a work in progress branch, obviously. That's only in the output. Okay. Yeah. Every time I search for other occurrences, they never exist. So more variables, temp scope is the local thing. We allocate the next variable that's used in the outlines. Now I need to think who is going to delete. So the subscript lookups don't need deletion. They are not new variables. What happens with the count variable? The count variable gets never deleted. It hopefully gets removed. But it may not get removed because of branches. So I guess I just removed the G, but if I had branches in here, I would iterator equals iter 1, 2, 3, and then I would do x equals next iterator, and y equals next iterator, but only if a condition occurs. And then so right now, because I'm checking for the unpacking iterator, that's not being dealt with. But if a condition occurs, this one is third or second, and the check actually cannot. Can it be done? Must it be done? Yes. Actually, the check appears to be wrong because I'm checking the original iterated, and I'm not checking. I feel like I need to check the count value. So how many values did I take? And is there more? If there's more values than I did take, then I need to complain. Not if there's more values than I expected. Although in this case it's an unpacking iterator check. There is no check in this case, so it doesn't matter. No, for unpacking I know how much. There is no doubt about the value at the end. So I don't have to use the real one. But in this case, I would certainly have issues. So yeah, what am I going to do next? Am I going to get brave and run the basic tests and see where it crashes? Let's do resume. Resume will automatically repeat the last crasher. Ooh, index error value. Yeah. Yeah, okay, I forgot about this one. Yeah, I forgot about that. Yeah. Too small iterable. Exactly. I'm getting an index error rather than a value error because yeah. So iterable is not long enough, but still, do I know it's a tuple iter? Why is it happening? Does my code optimize this? It doesn't know the type, so what tuple index? Oh. It should not have unpacked this. It should not have touched this one. So, okay, let's toggle line comment on this. And this should not have happened because I do not see how or why it would have done it. I mean, the bug is still valid, but that's a bit too optimistic. Wait, 1, 2, 3. It's even correct. Not crashing. What's with it too small? Yeah, this one. Yeah, of course. Yes. Yeah, okay. That's not what yeah, okay, this one it didn't do. So it's more like I think it may even statically decide that it's wrong. Propagated implicit race. Next value propagated for. Yeah. But here is assignment raises and then assigned exception and assigned value removed assigned value. Subscript predicted to raise an exception. So when it's looking up the element 2, it finds it's bad. And now what to do with that? We can either check the length and create an exception, or we do a special subscript node that changes the index out of range exception, like we do for the unpacking, or we really don't like to put for every tuple unpacking an exception, a specific one. Which one is it? This tuple index? No, the other one. Resume. It picked up an assignment. So Not enough values, expected 2, got 1. So how does it even have the, it has the total expected, right? So yeah, so I guess I can do this in the beginning. So this is actually a length check. And as we know, we may be able to do length checks on. So I can create a if length something, and I can make that a dedicated node at the beginning. It doesn't complain. I think the code, I think the complaint is a different one for that, isn't it? Because here it too many, yeah. Too many values. But I don't know. I don't know that. How do I know? Do I know what I'm expecting 2 values? I don't know how many iterations there are going to be. I'm the assignment node. I don't know. I don't know that. I just know one of them will be out of range. So actually, if I knew, and I do know, wait, only for unpacking iteration, I do know that. Expected length. I could have hints. I could not forget how much I expect there to be and do this in the beginning. But then I do not optimize manually created code like here, like this one. Not good for that kind of code. Here I would just tuple index out of error. Yeah, that's me. And what does the real thing say? The real thing says not enough values. Expected 3. The special unpacked has that knowledge, I think. Built-in iterator nodes. Expected. Yeah, it has a count which, no, not enough. Why is it not? It's only happening at runtime, huh? So far, there is only runtime optimization of this. Oh. Oh, this is something else. This is for start assignment. Yeah. This is a special case. No, usually it does only do this. There's no compile time equivalent of these. And yeah, either I make this special subscripts, which I do not like as much, because if I specialize this with integers and so on, it gets to be another dimension where I just add subscript of integer, and it's a special unpack and so on. If I do a try except in every of the outlines, I'm going to die from I don't know if it happens or not. I guess we're going to create a special. So in Python 2, that's not happening, right? Need more than one values to unpack. So that's the current index error. Still changes. Still needs to know how to reference the variable value. So I need to know which. I could make a wrapper. So that would be a node that passes all questions to its slave node, to its child node. And only when there's an exception, it will create a different one. Much like I've done it with overloads for the special. So built-in iterator nodes, iter1, special unpack. Yeah, this iter for unpack has a different exception. This could also have been done with a wrap of a node. And now here they inherit and just treat one thing differently. They could. The subscript nodes have, there's only one right now. Yeah, and then I need to specialize several of them and maybe have a mix-in or a reusable function. I don't like this extra nodes just to rewrite, especially when Python 3 is like it's the usual case now to have this and to have one of this and this, 2 times the memory, 2 times the delegation always will cost something. Don't like that. Yeah. Let me push it. Maybe this is something that an overload could also handle, like here it's creating an exception in the class and it's not even doing it itself. Anybody could do it. Yeah. No. Yeah, this is a problem. And this is also again just a rewrite of the I I can make these kind of wrappers, version dependent, switch between them. So I guess I would do variable reference nodes, subscript. I would not use those, but I would do expression. What's called built-in iterator nodes? Built-in expressions for unpack. Expression subscript for unpack. Do I put them into? Yeah, I probably will. It's still in subscript nodes. It will crash because of no code generation. Because obviously I also have to something with lookup. For unpack. It's very similar. And I will have to be told need more than one value. So I need to check the current count. And it's and subtract 1. So it's happening here. When I do -1 there. And of this variable, I need to know the variable. What I do? No. When I replace myself, I need to replace myself with a reference to that variable that hopefully still exists. Should be still existing. Because it's my subscript value. -1. And okay. So I do not need that for Python 2 and for Python 9. I do need the expected value. The expected value is something I was taking. I replaced the iterator. Did not keep it, right? The iterator node is long gone. Expected free. I am a second one. How do I know how many there are? If I assign the expected value into a variable, it will be removed by the time I assign it. So was it in the next node? It was here in the next node, I think. When I do the next one, yeah, I can. Where am I here? I don't know if I am a variable reference and the next node. Yeah, the next node. I will need the next node as well. Because the next node has that value when it's Python 3. Next node. No, does it? Yeah, it has the expected value. It has the expected value. Let me check that, but I'm pretty sure. Iter for unpack. Next nodes. Unpack. Yes, it has it. Variable ref nodes were doing it. And I need to make, I think I will make count an optional argument here, like next node equals get iter. I only need to be for unpack if it's an unpack node. Yeah, okay. If next node is the one for unpack node, is expression special unpack. Else. And if it's the one for unpack, we will create this one. Count equals next node dot count. Ansonsten none, otherwise none, and we do source here. Okay, now we make a difference. It doesn't have an expected value. It can give the standard error that iter will do, or next will do. Standard next will do, and then okay, so we need a count argument in this guy. Def init, yeah, it's all pretty neat, but I don't do it that way. And here we go, count e2 slots equals count. Remember the count, and there we are. Maybe we're still running. No. That should be an is check. Self, yeah, okay. Why? Oh. Like this. Same bug as before. Nothing changed. Actually, I like to develop in this way, like convince myself that I'm not changing anything for extended times. And now expression subscript lookup, compute expression subscript, much like we do with the other guy. I'm not sure it makes sense how I've done this with the iterator node. Like, I didn't. Okay. So this is actually supposed to be more like this. Result equals subnode expression, not value. Okay. Result node is that. If it's a raise exception of an index error. I want to see it. I think we statically optimize this right now. And this could fire. Yay. And so what were we supposed to do? So if count, if self count. Actually, I want to do it like this. If, wasn't it Python 2? Which version needs it? Really? All Python 3 has it. No, Python 3.5 has it. So if Python version 3.5 was the first one to have it. And then if count, which version? I'm not so sure when this gets used. Special unpack. Could have checked this. Okay, that's only here, I think. Why are we doing it for 370 only? This is a special case with it's almost, maybe this is wrong. Although I doubt, because I'm surely running tests It's a different one, right? The iterator. And what does the iterator do different? It is saying cannot unpack. Yeah, it's for a different kind of error. Oh, maybe I will get into trouble then because they are not this type. There will be some overlap, but let's not go there. But there may be some cases where it's sort of have this, but not the error, and the reformulation of the error message would then be the tracking of account. Although I have a special unpack. Yeah, the special unpack. I'm checking the wrong thing. The special unpack is the one which special unpack special. Yeah, this one here. Which one of these gets used? What's that criterion? Unpack. It asks start. So here it's not start. Always unpack. And this doesn't also not rewrite anything. So it's I'm confusing entirely different things. So subscript node, that's if count is not none. And I think due to slots. Let's not optimize this just yet. Okay. The self count is not none. You go figure. Making helpers. Node making helpers cannot unpack. This is not the correct messages. So the is need more than. Do I know the variable name still? Wait. So 3.6 has it. 3.5 has it. I need the current value variable. Need more than not enough values to unpack. Or maybe I start with the old one. Come on. Need more than. So if self count is none, need more than value. Really, is this plural? To unpack. Ah, come on. Operation iter. This is more like the operation is next. origin node is self, and value node is self sub node. What is value node used for? Size effects. So subscript clearly doesn't matter. The iterator reference doesn't matter. Why do I insist on the value node then? Because I have a shape, and the type name, and then it says, this is for type error replacements. It's wrong. It's wrong to use. Because I need to make a value error. Make exception. Yeah, I want to use this. The other one is a bit specific. Raising type errors, you can do more stuff, but so the template and the template args and the source ref. So and the template args. Yeah, now I need to well, actually it's my count, isn't it? Need more than no. It's actually expression variable ref. Oh goodness. And I guess I can get into trouble if this is not computed soon enough. I am computed. Is this other thing computed? Because no, it's my. I said that it's my subscript. So, and my self subscript is computed. So self subnode subscript. Oh, okay. But I need to add one or something, I guess. Let's see. Oh. Wait. Is that enough? Built-in iterator nodes. I guess I need to stop soon. Yeah, it seems to return the triple. Okay. And does this one too? No. No. Okay. Need to also say what I've done in erase. And raising or unpacking too short iterator. Okay. And now yeah, works. Just to making sure. This node has no code generation, so we did runtime optimization of this now. Oh, value error. Value error? Value error? Value error? No, it's not running. It's going to be version dependent. Count is not none. We are not being used. Is that true? I thought I've seen us before. Wait, is this correct? How is this then correct? I guess because it's not doing it at all for Python. Okay, yeah. For Python 2, it's not doing it because it's only doing it for unpack iterators. So Python 3.7 is the shortest, yeah, exception type. Okay. And I think it should be value error. And now, what did I say? If Python version not going to observe that, else branch, but the tests are going to find it. My CI is from Python version. Where is it? Yeah. Okay, not enough values to unpack. Expected percent. Why is it not D? Why is it not D? Good question. Not sure, but I think it becomes a string operation, right? Mod. Yeah. So could be percent %d. Should be value expected percent %d. God, they avoided the issue. Percent %d. So make constant ref node constant equals self count source ref equals self source ref. Yay! We're getting there. Delete syntax. What? My syntax is flawless. Fab brace is missing, but that's not it. Comma. That's pretty close, isn't it? Well, I have a -1 that I was speaking about. So the expectation. What? This is a different one. This got is always one off. I'm not sure I'm getting why. This 2 is I am the second element and I'm unhappy. And I only got 1. Just -1, isn't it? So is this subscript +1? Oh no, that's my code. And the real code says it was expecting 3. Okay, my code is off. Self count is off. Really. Where was count from? It hasn't. It's an expected. I was using count, but I should be using expected. Right? So I'm supposed to use this. So count is the current one. The current one is in the variable and the expected one is here. So expected, let's rename it to expected. Okay. Of course, but I only renamed the variable. Does it change anything? I have to pass it differently. Yeah, and now crash on the creating code and get expected. Let's use accessors for once. Expected. Expected 3 got 1. So that's pretty compatible. So if I do resume, will it just work? It does. And here we have a next thing. Yeah. Here we have a case where it wasn't statically optimized, but it's still being done. So yeah, let's see what we have. Yeah, it didn't see through this, so what does this mean? So that's pretty constant. Yeah, it would appear that the nested unpackings are not optimized well. Okay, but we need to do code generation. subscript continuation code. Yeah. Continuation. Concatenation is correct there. It's only here, bro. Concatenation. I hate these things. Much nicer. So, but subscript code probably needs okay, if I put the same code generation, just compile again, but it may, yeah, okay. I mean, if it doesn't fail, only the exception type will be wrong. Okay. This is actually plenty of differences. But I hope, oh, extended sequence unpacking. Yeah, okay. I know what's going on. I need to catch it where the iterator escapes, and in the star sequence unpacking it escapes, but we don't know, and then we do this optimization and it's wrong. Okay, that's enough for today, or for now. Maybe I will stream later. Again, thanks for watching. I'm not saying these magic YouTube thing. No. Okay. Bye.